Hello, I will explain here the simulation about the MACI V2 robot. MACI V2 is based on the MACI robot that is based on the Universal Robot 5. This is the result of part of the course of Dr. John Bial that is on LinkedIn. You can search it or you can view the description. There are several courses that are good for robotics. That this is one. The others are for Lentin Joseph, the Construct, and there are robotics backend, other YouTube channels that you can follow and see whether they are doing. Probably I will do a brief review about these robotic channels. There's also Automatic Addison, it's a good web page. Um, which ones are Robotic Magazine, Robotics Age, or something like that. There are plenty of good resources. So um, let's start explaining here what we'll do over the MACI V2 robot that is a robot arm based on your UR5. So here we have the launch description that will launch all these files. The closed launch description is like to get the source path for the launch file. The execution process is the same as execution things on the terminal, like this, but programmatically. The get package share directory is because Rust everything installs over a share folder in some build. That's to get this, or sometimes not this. Sorry, not this uh, uh, information. Just the name of the folder that is on the source. Sorry, node is obviously the node that you want to launch. Load Sacro, obviously load the URDF. Join and pad are for the system. And here I will explain everything here. It's very compact, so don't worry about it. Later I will explain MoveIt setup assistant and also what are the pitfalls that you will be uh, falling if you try to build your own manipulator or if you try to set up um, your simulation. So for this, we are first getting the path of the Gazebo simulator. We will try to launch the Gazebo simulator, so we get the path, and also we have these launch arguments that are the empty world. Later, we will run Gazebo simulator with the robot description that we will spawn later. This will spawn the robot on Gazebo, and we also get the URDF file over loading Sacro of the robot. We get here the object that is an XML file. Later, we will publish, given the XML file of the robot, we will get the join states and we will publish that's necessary because Rust needs to know which joins are or the state of the joins, which are. This node obviously start the controllers. This is the join state controller that control the joins, obviously. The R controller that I have a gripper here, and this gripper has two parts. One is the gripper only part, and the other is for the UR5 manipulator. So the UR5 manipulator has a tool point, and in the tool point I put a gripper. So here we will launch the or movie configuration that we made it. Later I will explain what kind of things you need to configure over MoveIt. Also we will see the URDF file about that. Um, Later also we will try to launch the MoveIt Arbis to launch everything loaded, the planner and other things. We also need the bridge, Rust Gazebo bridge, to bridge the clock sources of the sensors. Currently, we don't have sensors. If you have some sensors, then you will list here. And The package is Rosgazebo Bridge, and the parameter executable is the parameter bridge. And we'll try to launch over the screen. Last but not least, this is very important. You have to synchronize the message and the gazebo sync time or the RB sync time, everything together to follow all the information about the sensor. This is very important because you need to communicate at the same frame time. If not, you will get some kind of um, messy errors, and you will not don't know what to do. Usually is because the synchronization about the gazebo, the clock, the sources of the sensors, and MoveIt. So finally, we will launch gazebo, or will load our robot description, publish the states, also the controllers, launch MoveIt, launch RVs, the bridge of the sensors, and communicate to Ross the simulation time. So I will show you, and now uh, I could show you this thing working, but I decided right now to show you the URDF file and the setup assistant. So the URDF file here is consisting of this part that has the description of the URDF file. Universal Robots makes something very simple for us. We can specify the rotation point, the origin, also the word link. No, sorry, this is a part. The word link is a part of the instantiation of the robot. So for instantiate the robot, you have to include from this package the macro. So obviously you put a link, and when here we have the definition of our robot gripper. Later I will show you the gripper. Here is the gripper link and the finger link. We also join the finger with the gripper, and also we will join the gripper with the tool of the UR5. Finally, uh, here, okay, you must limit the effort here. We had to put something because it's a prismatic joint that will be launched to uh, uh, get only over this configuration, no more. And the velocity, just a parameter here. For configuration of the joints, we will also use the ignition system over the hardware and over the finger joint. So if you have more joints here over your gripper, you have to instantiate here. And finally, uh, don't forget about communicating that you will be using ignition ROS to control over gazebo. Gazebo and ignition are the same thing. They changed the name currently to gazebo. That was his previous name. Okay, probably I will try to launch FreeCAD. Let's move over terminal to see the gripper. This will take a little bit of time, so keep calm. Okay, in the meantime, I could explain. Okay, this is loading right now. Let's wait. Okay, cool. We have here FreeCAD here. I will open the gripper. FreeCAD gripper 2. Let's wait a minute. This loading simple information, but it takes some time because it's running out inside the container. So here we have this is a sole part, the base, uh, the base of the joints. This joint, this everything here, this and this is fixed, and the only one that is moving is here. So the gripper has gripper base link. That is this. It's a finger link. Is here, and that's all. The other thing is the joint that merge the finger with the gripper. So this is everything about the prismatic joint. Okay, let's move on here. Okay, now that you see what is happening here, now recapping, you have a finger link and finger and gripper base link. We are attaching to the UR5. Now let's jump to MoveIt. So let's move to MoveIt. ROS 2 launch, MoveIt, setup assistant, MoveIt, setup assistant. Um, so, sorry, it's ROS 2 run. Okay. Okay, the first thing that we know here is that let's move this thing a little bit. Hmm. Okay, it's not moving. Let's see. Okay, on the bottom. Anyway, what I'm trying to tell you is that here we have the complete manipulator. Is the manipulator and the attached pad of the gripper. At first, we need to compute the collision matrix, so you get the collision matrix here. If you don't get the gripper here, is because, and that's one of the things that I must tell you, you have to put here file over the define robot description mesh that you generated. If not, probably this will not load here. So let's see, we have the gripper. Let's see. Okay, we have here the collision matrix that is everything here because the self robot is an entire rigid body. We need to set up the collision matrix because if not, this when it's loaded in RBs using MoveIt will be appear in red, and if it's in red, you when you compute the movement, it will say it will collide and doesn't move, doesn't plan or replan. So that is very important to establish pretty well the collision matrix. So here you could establish virtual joints. We will not not do anything. We have here the controllers of, or sorry, the planning groups. So in the base, we will chain the arm with the tool, and finally, for the joints, we will put the gripper. Some joints are revolution and other are prismatic. For example, here we have a prismatic joint over the gripper. The gripper cancel or the arm. Let's see. Okay, edit select. Here you can edit the kinematic chain and find everything. And also for the joints, you can check here the joints that you are planning to be inside. For the robot poses, I put two poses. These ones, the N effector. This is the N effector. I think I'm seeing not the correct MACI robot. Let's see. Source. Okay, to move it. Choose load files. Okay. No, it's okay. So, for example, you generate collision matrix here. Everything is generated. You have the virtual joints, the arms, the gripper. You can edit the gripper. We only have this here. The robot pose, I only put one pose for this one. The N effector, that is the gripper. I will move it here. Passive joints, ROS control, we are using the positions and velocity. We start these ROS controllers, these movie controllers. We don't have perception, but this usually over selects again. This launch file, we don't want to specify the warehouse, author and configuration file. If when you are ready, you click generate package and that's all. So I will click exit because I have it configured previously. Okay. Important things I told you about the how to avoid doesn't see anything over the gripper attached to the arm. The next thing lets me check because I take notes here. Hold on. Okay, let me see. Yes. Okay. One thing is this thing. For example, if you don't see your gripper, you have to put file and find over the what you are looking in the MACI V2, robot description, the meshes, and the name of the meshes that you're using. Okay. The next thing is if you want to rotate, for example, you want to rotate the robot over axis, you have to put origins over the gripper. For example, this is the roll or X rotation, pitch, the Y rotation, and the yaw. This is the rotation. What other thing I need to tell you? Let me see. Hold on. Mm, I thought I put it over here. Okay, I don't remember where I put, but for example, another problem that you will have is crashing MoveIt, and that's because here on the MoveIt configuration there is a file named join limits. This file and the joins, everything that is here that is uh, integer must be float. Don't know why, because he's looking for float and is encountering something about the column. I think is not configured a float, and it will crash. So for every integer that you find here, point a point zero, for example, and you will be safe. Another thing that uh, you will see is that okay, on the URDF file here you have to comment here. That's not a big deal. The other thing is I can move it. No, I can to move it. You have to. Sorry, it's on MACI. Here you have to. If you get an origin error, so for example this error, annexation, something that says origin, that's because on your URDF file you put um, uh, some inertial information and you are missing. So the one fix is to remove the inertial part and keep it simple. The other error is related to um, where is okay. Okay, I don't remember where I pointed, but I remember that the other error is about this. If you don't put this sometimes when you are trying to launch your file, you get that you cannot read these ones. So that's the error. No, so for the final part now, we are trying to launch the entire system. Uh, let's launch it. Okay, this will launch Arbis and Gazebo. I will play here to load the controllers. And if you let's check about this Windows later. I'm interested more on these things here below. This command, select these packages only and compile it. We'll, later we have the source everything and launch this file that is over this folder in the launch file folder of MoveIt. I will start robot compact, this file I explained previously, and everything everything that we put on that file happens here. We get publishing all or everything about the robot and other points. We also add move it to the to Arbis. There are some things that are happening here about move it. Everything goes okay. Ignore this error. It's something about Ruby. And here we are launching the move group. Here then spawns everything over the move group. Later we'll load the controllers here. The joint test broadcaster is configured, the R controller, the gripper controller, and if you don't press play on Gazebo, it will not happen. It just only load the joystick broadcaster. So you have to put play or start or play on Gazebo to start the ARM controller and the gripper controller. When everything goes okay, you will get this window. That is the planning window of Gazebo. That's a little error that I have here and have to correct. I will do later. Here we have with our ARM, and we can plan for the ARM here. Let's move. For example, okay, let's select and move the direction of the arm just to play a little bit and move over and plan and execute, and the arm start moving to the position that we requested. If we want to move the joint, then later you can switch to the gripper and move the joint gripper here, for example, to this position. Let's show here. Okay, and here. Okay, with planning, we plan and execute. Boom, and execute it. And doesn't move. Let's see. Yeah, planning, gripper, state, current goal. Let's put a random value to see something. Okay, let's try to launch this again. Let's put play. Here, try to launch to move it, and the joint also move. Oh, sorry. And for the gripper, to move the joint a little bit, and then plan and execute. And this move here. Here it moves. Probably you don't see it because it happened too fast, but let's move again the joint. And plan and execute. Here it is. Okay, that's all. Everything worked not flawlessly, but worked pretty good. I hope you understand a little bit about how to configure everything. It's very tricky and very confusing sometimes, but I hope this guide or quick guide also keep you in touch with manipulators and some other robots. So thanks.